we have to determine the horizontal deflection. Okay, so horizontal deflection at D. So we have here the D. So we have to determine the deflection here at D, horizontal, and the rotation at B. Okay, so rotation at B of the given frame using the virtual work. So we have here the given real beam. This is our real beam. So we have a frame, I should say frame. So we have AB, we have uniform load, horizontal load. For BC, we have a downward concentrated load, and we have CD. Okay, so if you noticed, our moment of inertia for AB, BC, and CD are not the same. Okay, so you have to take note our moment of inertia. Okay, so in solving for the deflection and rotation of a structure, you need to first find or compute the reaction at support. Okay, so computing for the reaction of our real beam, we have here. Okay, so we have our reaction, we have a support at A and support at D, roller support at D. So at A, we have a pin. Pagka maalala nyo ang pin support, we have two reaction, horizontal and vertical. Okay? And for the roller, okay, we have vertical reactions and horizontal reaction at roller. Okay, so solving for the reaction, we have to take the summation moment at A, summation at A, to find for the reaction at D, the vertical reaction at D. Okay, so taking our summation moment at A, RDV is equal to 43. Okay, and if you take our summation forces vertical, we can solve the reaction vertical of A, that is upward 7. And if you take the summation forces horizontal, we get the reaction horizontal at A. Okay? So, if you still remember, if we have pin, we have 3 unknowns. Up, fix 3, 2, pin, and for roller, we have vertical reaction. Okay? So we have now solved the reaction RAH horizontal. This subscript H denotes that it is an horizontal, V for vertical. Okay, so RAV, we have 7, and the reaction vertical for D is 43 kilonewton. Okay, so after solving for the reaction of the real beam, we have to draw the free body diagram of our virtual system. Okay, for deflection and slopes, since we are going to solve deflection and rotation. So we need to draw the free body diagram of our virtual system for both deflection and rotation. Okay, so we have here for the deflection, we have here the free body diagram for the deflection. To draw the virtual diagram, you have to remove all the loads of the frame. Okay? So, walang load. Nawala yung uniform load natin sa AB and uniform natin sa BC. And replace it with a unit load at a location of the deflection you want to solve. Okay? If that is for the deflection. For the rotation, you have to draw the virtual diagram, remove all the loads, then replace it with a unit couple on your desired location. Okay? So for the deflection, we have here the FBD, the free body diagram. So remove all load and apply 1 unit load. Okay? So we apply 1 kilonewton assumption to the left direction. Ito yung assumption na direction natin. Okay? 1 unit load at D. Okay? So if you apply 1 unit load at D, isosolve din natin ulit yung ating reaction. Okay? So for the FBD, for the virtual diagram for deflection, if we apply 1 unit load here at D and take the summation forces or the equilibrium equation, we can solve for the horizontal reaction at A, vertical reaction at A, and the vertical reaction at D. Okay? So this can be solved using the equilibrium equations. Okay? So this is for the FBD for deflection. How about for our rotation? Okay, so to draw for the virtual diagram, for the rotation, we have to remove all the loads and all the loads of the beam and replace it with a unit couple. So sabi sa problem, we have to determine the rotation at B. Okay, so we have to apply our 1 unit couple at B. Kaya meron tayong 1 unit couple. Okay, so ito yung in-apply natin sa B. Okay, so if we apply 1 unit couple here at B, we can solve for the reactions at our support. Okay, so using the equilibrium equation, we can solve for the RAH, which is 0, RAV 0.2, pababa siya, and for RDV, that is 0.2. Okay, so you have also to check if my calculation here is correct. Okay, so if we use equilibrium equation, we can solve for the reactions for the free body diagram in virtual work for the rotation. Okay, so this will be now our FBD for rotation. Okay, so we have 0, 0.2, and 0.2. Okay, so after which, if you have now your free body diagram for your virtual system for both deflection and slope, since we are going to solve for the deflection, horizontal deflection at D and rotation at B. Okay, we are now ready to cut our segments into frames into segments. Okay, so for deflection, unahin natin for deflection. This is for the deflection. Okay, so this is now for our deflection. For the deflection, segments of the real beam should be the same for the virtual diagram of the deflection. Okay, so for deflection, we have here our real system, and later makikita nyo yung virtual system natin. Okay, so to solve for the deflection, the segments of the real beam should be the same for the virtual diagram of our deflection. Okay, so let's take this as our real system to solve for the deflection. Okay, so pagka frame, we have to separate our segments of frames into beam. Okay, so we have AB, BC, CD. Okay, of course, we have to take yung na-solve natin kanina na reaction. Ito yung mga na-solve natin na reaction kanina. So, meron pa rin yan. And of course, yung given load, meron pa rin yan. Ito yung mga given load. Okay? So, if we separate our frames, into parts of beams and cut it into segments, makukuha natin yung ating bending moment equation. Okay, so we have AB, BC, and CD. Unahin natin. For uniformity na lang in the class, kindly take if we have a frame problem, from left to right tayo. Okay? So can we start from left to right? Para ma-check ko din kung tama yung pinaglalagay ninyong direction. Okay? For the uniformity. So we take our segments and equation starting from left to right. So unahin natin sa AB papunta sa D. Okay? So unahin natin itong beam AB, column AB. Okay? So if we separate that, wala pa ito wala pa yan. Wala pa yung 7 dito sa taas. Wala pa yung rotation dito sa moment at B, A. Okay? And this is B, BA, reaction at BA. Wala pa yan. Okay? So, ang meron lang tayo yung external loads natin na reaction, RAH, RAB. Okay? Pagka sinaparate natin yung AB, pagka sinaparate natin yan, magkakaroon tayo ng moment and reaction dito sa my point B. Okay? So, if we take the equilibrium equation, we can solve our RB reaction at BA, that is equal to 7 kilonewton. Summation forces vertical, okay? So we have RAB, then RBV. Okay? Nag-summation forces vertical tayo para makuha yung 7. Okay? And taking moment at B, yung 90 pala dito is the MBV. Ito pala yung load natin, 5 kilonewton. Okay? Mali yung na-encircle ko. Okay? Ito yung original load natin, 5 kilonewton meter. Okay? So for AB, if we take summation forces vertical, we can solve for RBA, which is 7 kilonewton. And if we take our moment at B is equal to 0, we can solve for our moment BA, that is equal to 90 kilonewton meter. Okay? So magmo-moment kayo dito. Okay? Kaya meron tayong 90. Okay? And then, yung na-solve ninyo dito, that is the reaction BA and then moment BA. Pagkapunta ninyo sa BC, segment BC, pagkapunta ninyo dito sa beam BC, i-carry nyo yun. Okay? Opposite direction. Para pagkapatong nyo ito, 0 yan. Okay? Pag wala siyang internal na reaction kasi frame na tayo. Pero pagka pinaghiwalay nyo, meron tayong reaction. Kaya opposite para mag-0 siya. Okay? So pagka downward ito, sa BA, pagkapunta nyo sa BC, magiging upward yan, 7. Okay? Pagka counterclockwise ito, since counterclockwise yung na-solve natin dito, magiging clockwise dito sa BC. Kaya 90 is clockwise. Okay? So we have now reactions at B and moment dito sa BC natin. Okay? The same pa rin yung 50 kilonewton. If we take summation forces vertical, makukuha natin yung RCB, which is 43 kilonewton. Okay? And if you take moment here at C, pagka nag-moment kayo dito, ang moment natin dyan, 0. Okay? Kaya wala tayong nilagay dito. Okay? That is 50 times, ano yung distance natin dito? 2.5. Negative 50 times 2.5 plus 7 times 5 plus 90. Magzi-0 siya. Okay? So, ito yung nakuha natin. And pag ano yung nakuha nyo dito sa C, opposite direction, yun yung ilalagay ninyo sa susunod na beam natin sa frame. Okay? Yung column C, D. Okay? So, 0 yung moment. So, wag na tayo maglagay ng moment. 0. Pagka pataas yung CB, pababa yung CD. Okay? So, that is 43 na pababa. Okay? And pagka nasa last na kayo, dapat yung summation, equilibrium equation natin is 0. Dito, summation forces vertical should be 0. Okay? Pag hindi nag-0 yan, may mali sa solution ninyo. Okay? Kailangan sa last, summation forces vertical, summation forces horizontal, and summation moment should be equal to 0. Okay? Ito, summation forces vertical is equal to 0 kasi pababa na 43, pataas na 43. Mag-i-equal siya ng 0. Okay? So, ganyan. So, yan yung magiging real beam natin. Okay? So, after which, yung segment natin for AB, isang segment lang yan. Wala tayong changes in load, wala tayong changes in I. Okay? So, uniform load, isa lang yan. Kaya isang segment. Nag-segment tayo dito and we take that as X. Okay? For BC, we have a change in load after 2.5. Okay? So, we have a change in load of 50. Kaya, yung segment natin dito, dalawa. Okay? I take my origin at B and I take the other at C. Okay? So, yan yung segment natin. And of course, sa my D. Okay? So, I take that as my cutting segment. Okay? So, apat yung segment natin all in all. We have AB, B, let's say this is E, BE, CE, and CD. That is for the real beam. Real beam pa lang tayo. Okay? Pagkapunta natin sa virtual system natin in our free body diagram, the same procedure, we have to cut the frame and we have to solve for the internal forces. Ito yung mga na-solve natin, yung internal forces. Kung ano yung ginawa nyo dito sa real beam, yun din yung gagawin natin dito sa virtual FBD ng virtual for deflection. Okay? So, yung RAH, that is the reaction, yung na-solve natin. Ito yung mga na-solve natin kanina. Okay? So, hiwal-hiwalayin ninyo. Okay? So, if we take yung AB, wala tayo nito. Ito yung mga isosolve pa lang natin dito. Okay? So, for AB, this is for the virtual system for deflection. Okay? So, for AB, if we take our summation forces vertical, masosolve natin itong 0.4. Pababa na 0.4, kaya pataas itong 0.4. Okay? So, if we take our summation forces horizontal equal to 0, positive, makukuha natin itong 1. Okay? Kasi to the left yung 1 na ito, to the right itong 1. Okay? And if we take our moment at B, masosolve natin yung 6 kilo Newton meter. Okay, so 1 times the distance, that is 6. Okay, clockwise ito, counterclockwise yung B. So that is 6 kilonewton meter. Okay, so kung ano yung cutting segment natin sa real beam, yun din yung cutting segment natin dito sa virtual. So dito tayo magka-cut. Okay, so kung ano yung na-solve ninyo sa internal forces dito sa B, yun din yung magiging internal forces dito sa BC. However, opposite direction. Okay? For example, dito sa 1 kilonewton to the left, magiging to the right pagkapunta nyo ng BC. Okay? Pagka-upward, magiging downward. Okay? And pagka counterclockwise ito, magiging clockwise dito. Okay? So ito, parehas yan, opposite direction. Okay? So internal forces yan. Pagka pinagdikit yung magzi-zero yan. Wala siyang external. Okay? So pagka meron na kayo dito, masosolve nyo na din yung internal forces dito sa C. Okay? For B, C. Summation forces, yung equilibrium equation pa rin yung gagamitin natin to solve for 1 kilonewton, 4 kilonewton meter, and 0.4 kilonewton. Okay? So if we take summation forces, vertical, this is upward. This is not downward. This is upward. Okay? Since downward yung B, dapat upward yung C. Okay? Kindly check this. Upward itong C. Okay? And clockwise yung 6. Pagka nag-moment kayo dito, remember, meron pa tayong 0.4 times the distance. Okay? Pagka nag-moment tayo dito, magiging 4 kilonewton meter. And summation forces horizontal, 1 to the left, kaya 1 to the right dito sa may C. Okay? So kung anong na-solve natin dito, yun din yung ilalagay natin sa may CD. Okay? Opposite direction. Kaya pagka upward, ito, sa may BC, yung C natin, reaction at C, downward dito. Pagka to the left, to the right na 1. Okay? And counterclockwise, clockwise dito. Okay? And if you take the summation forces, yung equilibrium equation natin, dapat mag-zero lahat. Okay? Summation forces vertical, 0. Pagka nag-moment kayo dito, dapat sa D, 0 yan. Okay? Kasi wala tayong moment dito. Okay? Summation forces vertical, pababa na 0.4, tama, pataas na 0.4. Okay? Yung moment natin, pagka nag-moment tayo dito sa C, dapat 0 yung moment natin kasi walang moment ang roller. Pagka nag-moment tayo dito, 4 times minus 1 times 4. Kaya 0. Okay? So yan na yung mga internal forces natin sa frame natin in our virtual system. Yung free body diagram natin for deflection. Okay? For deflection. So after which, we can now solve for the deflection. Okay, so before solving yung deflection natin, magti-table moment equation muna tayo due to real and virtual load. Okay, so we have here, for segment AB, I assume clockwise. Clockwise din yung BE natin, CE counterclockwise, and CD counterclockwise. Remember, apat, diba? Apat yung cutting natin, AB, BE, CE, and CD. Okay? So yung AB, ang origin natin is at A. Sa BC, ang BE, ang origin natin is sa B. Sa may CE, ang origin natin is sa may C. And for CD, ang origin natin is sa D. Yun yung magiging 0 natin. Okay? So tignan lang natin yung distances. We have 6, 2.5, 2.5, and 4. Okay? So pagkapunta natin dito, origin, A, B, C, and ito yung magiging 0 natin. Okay? So for the limits, yung AB, 0 to 6. Okay? Pagka nakita nyo kanina yung diagram natin, 6 meter yun. Okay? 6 meter ito. Kaya 0 to 6. So yung BE, remember, ito, dito, sa center dito, 2.5 ito, 2.5 dito. Okay? So, 0 to 2.5, kaya 0.2.5. And C is 0.2.5 since yung origin natin, yung x is equal to 0 natin, is sa may C, kaya 0.25, up 2.5. And CD is 0 to 4. Okay? Our I, given yan sa problem, lagay lang natin dito. Yung I natin, given to sa problem. Okay? And for the moment equation. For the moment equation. Okay? Pagkapunta natin dito, pagka nag-cut tayo dito, tapos mag-moment tayo dito, anong imo-moment natin? Yung RAH, and then yung uniform load. Okay? So that is 30x. Clockwise tayo, di ba? Positive, that is 30x minus yung 5 times x over 2. Okay? Pagka nag-cut tayo dito. Ayan yung magiging moment equation natin. Okay? So, pagka nag-cut naman tayo dito sa may BE. Ito yung BE natin kanina, di ba? Okay? So, for BE, pagka nag-cut tayo dito, tapos nag-moment tayo dito, ano yung imo-moment natin? Yung reaction na 7, tapos yung moment na 90. Okay? Clockwise positive, kaya ang magiging equation natin dyan is 7x plus 90. Tama? Okay? 7x plus 90. And pagkapunta natin dito sa may, okay? So pagka segment CE naman tayo, tapos nag-cut tayo dito, magmo-moment tayo dito, ano yan? That is, ang assumption natin counterclockwise is positive, right? Kaya pag nag-moment tayo dito, ang i-moment lang natin yung 43. So that is 43x for CE. And then for CD, ito yung naging cutting plane natin. Ano yung i-moment natin dito? Wala, di ba? Kasi you cannot take moment dito sa vertical kasi ano siya dito sa may beam. Wala tayong horizontal, kaya yung moment equation natin is 0. Okay? So we have 30x minus 5x over 2, 7x plus 90, and 43x. Tapos 0 sa may segment CD. Okay? Pagka nag-take naman tayo dito sa may deflection. Pagka nag-take naman tayo dito sa may deflection, nag-cutting plane tayo dito. Tapos magmo-moment tayo. Ano yung moment natin? Yung 1. Okay, so clockwise yung assumption natin. Kaya yung magiging moment equation natin dyan is 1x. Okay, pagdating natin sa BE, okay, nag-cut tayo dito, tapos mag-moment tayo dito. Anong magiging moment equation natin dyan? Okay, ang assumption natin sa BE is clockwise positive. Clockwise yung 6, kaya 6. Tapos yung vertical, okay, counterclockwise siya, kaya minus 0.4x. Okay? And pagkadating natin dito sa may CE, okay, ang assumption natin, clockwise positive. Clockwise itong 4, kaya positive. Okay? Kanina sabi natin patas ito, di ba? Kanina. So, counterclockwise positive plus 0.4 of x. Okay, so ito yung magiging equation natin for CE. And lastly, for CD, okay, dito tayo nag-cut. Anong imo-moment natin dyan? Yung 1. Ang assumption natin dito, counterclockwise positive, kaya positive 1x. Okay, so yung equation natin, ito yan sa ating table. Okay? So, yan yung sinolve natin kanina. Okay? So, pagka meron na kayo niyan, meron na kayong equation, you can substitute this in our virtual expressions. Okay? So, the integral, pagka deflection, integral of x dx over EI. Do not forget yung EI natin. Okay? So, if we substitute our values in our expression, ito yung magiging value natin. Okay? Ito yung M, ito yung MX, ito yung M, ito yung MX, ito yung M, ito yung MX. This is for segment AB. Substitute lang ito dito. BE and CE. Bakit wala yung CD? Remember, yung moment equation natin doon sa real beam is 0. Okay? Kaya 0 yung masasolve nyo rin. Kaya kahit hindi nyo na ilagay sa solution. Okay? So kindly check if my calculation is correct. Paki-check nga ito pagkatama yung calculation natin. That our summation for horizontal For D, the deflection, horizontal at D.
Yes, ma'am. Gusto.
Okay, tama. Okay. And calculating, our deflection horizontal at D is equal to positive 1,335.42 over EI. Okay. So the positive means our assumption is valid and our deflection is to the right. Yan yung deflection natin. Okay? So, for the rotation at B, nakuha na natin yung free body diagram for rotation. Right? Nakuha din natin yung reaction due to the virtual system for rotation. Okay, pagka nag-apply tayo ng 1 unit load doon sa may B. Okay? So, after which, kakat na natin yan. This is for the rotation. Okay? So, pagka tinitignan kasi natin yung rotation and yung sa may real beam, parehas lang yung cutting. Doon sa cutting natin dito sa deflection. 4 yung segment natin. That is AB, BE, CE, and CD. Okay? Parehas din doon sa rotation. Kaya yung magiging real natin, yung cutting natin sa real system natin for rotation, parehas dito sa may deflection. Okay? Ito pa rin siya. So, parehas pa rin yung equations, moment equations natin. Okay? Kailangan lang nating i-solve is the equations for the virtual doon sa ating rotation. Okay? So, ito yon. Okay? So, ito yung na-solve natin kanina na reactions. Okay? So, the same process to solve for the internal forces, yung BA 0.2, that is summation forces vertical. Okay? Pagka meron tayong rotation at joint, di ba? At joint kasi, joint yung B natin. Doon tayo naglagay ng 1 unit couple kasi yun yung hinahanap natin na slope. Okay? Pagka meron tayong joint, separate natin yan. Ito, joint B ito. Okay? Meron tayong joint B kasi meron tayong 1 couple dito sa my joint B. Okay? So, after yung AB, magjo-joint B muna tayo kasi meron, ito yung unit couple natin. Or kung meron kayong moment sa joints. Okay, na-given. Okay? So, mag-joint tayo. Pagka nag-joint tayo dito, pataas na 0.2, kaya pababa na 0.2 dito. Okay? Pababa ito, pataas ito. Okay? So, we have clockwise, kaya counterclockwise itong 1 kilonewton meter natin dito. Okay? So, after joint, punta na kayo sa BC. Kung anong na-solve ninyo dito, yun din yung ilalagay nyo sa BC. Opposite direction. Kaya pataas ito, pababa dito. Counterclockwise dito, clockwise na 1 kilonewton meter. Okay? And if you take moment, summation forces vertical, masosolve nito. Summation moment, 0 yung magiging moment natin dito sa may CE, CB. Okay, dito, 0 yung moment natin. Okay, equilibrium equation pa rin yung gagamitin ninyo to solve for the internal forces. Okay, so kung anong na-solve natin dito, ilagay natin dito sa CD. Okay, so sa beam CD, pataas, magiging pababa. Summation forces vertical, dapat mag-0 siya. Okay, so sa mga equilibrium equation, summation forces vertical, 0. Okay, so ito na yung magiging free body diagram natin for our rotation in our virtual system. Okay, so yung cutting plane natin sa real, yun pa rin yung cutting plane natin since wala naman tayong changes in load here in our rotation. Okay, so 4 pa rin. So we have AB, BE, tapos CE, tapos CD. Okay? So, for the equation here at rotation, since doon sa real system, parehas yung equation natin doon sa deflection, yung na-solve natin sa deflection. Okay? So, dito, isa-solve natin ito. Ano yung magiging moment natin dito? Pagka nag-moment tayo dito sa ating cutting plane. For AB, ano yung magiging moment natin dito? 0. Okay, for BE, segment BE, pagkapunta natin dito sa BE, pagka nag-cut tayo dito, ano yung magiging moment equation natin?
Ma'am, 1.
Kulang pa. Ituloy mo. 1,
1 kilonewton.
1x, ma'am.
1x? Are you sure?
1 kilonewton dot meter. Kasi naka-moment na siya po, ma'am.
Nakalimutan nyo
1
yung
minus x.
reaction.
2.
Nakalimutan ninyo yung reaction natin. Pagka nag-moment kayo dito sa cutting plane, pagka moment, hindi nyo niya i-multiply ng distance na x. Kaya 1 lang yan. Ang nakalimutan nyo, yung reaction natin na pababa sa B. Kaya meron tayong minus, since this is counterclockwise, nag-moment kayo dito, counterclockwise, pag ganyan, nag-moment kayo dyan, we have minus 0.2 of x. Okay? So, yan yung magiging moment equation natin dito sa BE. Okay? So, pagka dito naman sa CE, pagka nag-cut tayo dito, ano yung magiging moment equation natin for CE? That is, ang assumption natin kanina, counterclockwise, ito is positive. So, ano yung magiging moment natin for CE?
0.2.
We have 0.2x.
2x.
Okay? Since reaction ito. Ano yung magiging moment equation natin sa CD, in our virtual? Rotation.
0, ma'am.
We have 0. Kasi pag nag-moment tayo dito, wala tayong imo-moment dyan, kaya 0 yung value natin. Okay? So, AB, 0. BE, 1 minus 0.2. CE, 0.2x. And CD is 0. Okay? So, yung real system natin, the same. Kaya yung value, yung moment equation natin, the same. Okay? Yan yung moment equation natin kanina. Yung nakuha natin sa deflection, yun din yung real system natin. Kasi the same din naman kasi yung ating cutting planes sa segments. Okay? Ito na ngayon yung na-solve natin na equations for the slope. Okay? Substituting this value in our virtual work expression, pagka sinubstitute natin yan, yan. Yung una, yung AB at CD, kahit hindi nyo na yan isolve kasi 0 ito, may 0 siya. Pagka minultiply nyo yan, 0. 0 din yung CD. Kaya yung i-consider lang ninyo is yung BE at saka yung CE. Okay? So, yan. So, kindly check if my calculation is correct. If we substitute the moment equations for both the real beam and for the virtual, for rotation, we get rotation of B that is equal to 1825 over 24. Okay? So, positive means that our assumption counterclockwise ay clockwise. Clockwise, iba yung assumption natin. CW is clockwise. Clockwise is correct.